Okay, so what we're going to talk about today are the properties of logs. So let's try this. It says, just a little review. Write it in exponential form. So take it out of log form back into exponential of the inverse. So remember, the base is always the base. My base is 3. And then these two guys, they switch. So it's 3 to the 4th is equal to 81. Okay, so let's look at the other one. It says write in log form. So you're going to take your inverse and put it in the log form. So it's going to be log. Remember, then you put down your base, and it's lower than the log. My base is 7. So log base 7 of, and then these two guys switch, the x and the 2. Log base 7 of 2 is equal to x. Okay, so now let's talk about common logs. All right, so a common log is when there is no base given. So when you have no bases given, it is considered base 10. So just like, remember I told you when you have a square root, there's a number that's always written here. But when there's no number written, we assume in math that that means a 2. So it's the same thing. When you see a log written, like log, let's say 100, you have to assume and know that no base written is actually base 10. So, for instance, when I have log 1,000 here, notice that there's no base written here. So that's really log base 10 of 1,000. Now, what's nice is that your calculator will do base 10. All right, so look for the log button on your calculator. It's right next to the 7. So just press log and then type in 1,000 and hit equals, and you will get 3. And that makes sense because this is saying 10 to what power is going to give me 1,000, and that's 3. All right, let's take a look at number 2. So a tiny bit different. So no base is written, so there's really a base 10 there. So this is saying 10, remember these guys switch, to the 3.336486 power. You can't actually read that, so let me rewrite it. So no base written is really base 10. So this is log base 10 of n is equal to 3.336486. And what this means is 10 to the 3.336486 power equals my n. So you plug that in your calculator, 10 caret key 3.336486, hit enter, and you get 2,170.131246 is equal to n. All right, so let's take a look at number 3. So this says log of 0.01277. So this is saying log base 10 of 0.01277. So that you could just plug into your calculator. So type in log 0.01277. Hit enter, and you get negative 1.89 and so on. Okay, so you write out the whole entire decimal. All right, so that's common logs. We're going to talk a little bit more about common logs tomorrow in class, just a little bit more about your calculator. Okay, but I wanted to do it with you guys in class. All right, so now let's talk about the change of base formula. So I just said up here that your calculator will do base 10. So then how do you do other problems? So how could I do log base 2 of 32 with the calculator? So remember, if I'm looking for what this is equal to, I would have done before 2 to the x power equals 32. And I would have to get the same base, set the exponents equal to each other. But there is actually a way to do this in the calculator, and it is called the change of base formula. So to do the change of base, this is the rule, log base a of x equals log x divided by log a. And what this does, it puts your log in base 10. So I always tell the kids it's log of this guy because it looks like it's on top of the a. So that goes on top over log x, sorry. Looks like it's on top of the a over the log of a. So instead of doing this problem here by getting the same base, and I'm talking about 2 to the x equals 2 to the 5th power, right? Set the exponents equal. Obviously, this is easy. All right, you can do the change of base. So what you would do is, oops, sorry. So what you would do, let me just rewrite this, log x over log a. You would do log of 32, right, because I did log of x, divided by log 2 over the log a. So log 32 divided by log of 2. So just type this in your calculator. Type in log 32. Now, be careful, because when you do log of 32, it gives you parentheses. So make sure you close it before you hit divide by log 2. Okay, and then hit enter, and you get 5. All right, so let's try it with log base 3 of 27. So that would be log 27 divided by log 3. Okay, plug that in your calculator, and you actually get 3. Okay, so now let's talk about the properties here. Right, so I just need to change my page. Okay, so there are 3 log properties. You have to know these properties. So notice in number 1, 2, and 3, there are 2 of them, but they are actually the same thing. I just wrote one of them showing you in the log form, and remember we have that natural log. It's the same thing for the natural log, for the natural base e. All right, so when you have log a times b, because I have ab, that means times, we separate it. Look at what it's over here. It separates with a plus in between, and then each one gets a log. And the same thing for ln. ln a times b is ln a plus ln b. So remember our exponent rule where we had x to the a times x to the b, and that was x to the a plus b. That's where it comes from, right? So I'm multiplying, so they separate with a plus. So take a look at the next one, the division. I have log a over b. They separate with a minus. So it's log a minus log b. And the same thing for ln. ln a over b is equal to ln a minus ln b. So remember that rule, x to the a divided by x to the b is equal to x to the a minus b power. That's where this rule comes from. Okay, when you have a division, they separate. Each one gets a log with a minus. All right, now this one here, this power to a power here. I have log a, and it has a power of c. So what happens is the c goes in front of the log. The exponent goes in front of the log. So I get c log a. And the same thing for ln. So it's ln a to the c power is c ln a. All right, so let me just move all this stuff out of the way. And what we want to be able to do, and we want to be able to do this, easily, so we're going to spend a couple days on this, is we are going to have to be able to expand and condense the logs. So for the expand, right above here, I want you to write, to expand, always change radicals, so if you have any radicals, to exponents first. So remember, radicals are power over the root to make it into a fractional exponent. All right, so I look at the first one, and I see log a squared y to the 3rd power. So I want to expand it. So expand would mean going from one log, and then when I'm done, I should have multiple logs. Okay, so the first thing I'm looking for are any radicals. I don't see any radicals. I have exponents, but I don't have any radicals. All right, now, you can't, because of these exponents, you can't go and do number 3. And the reason why is because number 3, in order to move the c in front of the log, you have to have log a all by itself. I don't have log x by itself. I have log xy. So it has to be by itself. So x to the 2nd, y to the 3rd, what's in between x to the 2nd and y to the 3rd is a multiplication symbol. So I want to use the first one. So it's going to be log x squared. Then I get to my multiplication. As soon as I get to my multiplication, I put a plus. And then this guy here gets a log. Log y to the third power. So I used rule number 1. Multiplication became a plus, each one gets a log. Now I can use rule number 3, where the exponent goes into the front of the log. So the 2 is going to go in front of the log. The 3 is going to go in front of the log. So it's 2 log x plus 3 log y. And that would be my final answer. All right, so let's take a look at number 2. So I notice I have log the square root of a over b squared. So right away I notice that there's a square root. I have to simplify that first, and I want to write it as a fractional exponent. So this is actually log a. Remember that a 1/2 is, that a square root is 1/2. So this is log a to the half power over b squared. All right, now I'm going to condense. Remember, I cannot use rule number 3 until I get my a and my b by itself. So you have to use the division rule, which is here. So use this one first. So remember, a division, they separate, each one gets a log with a minus sign. So it's going to be log a to the half power minus, because I came to a division symbol, log b squared. Now I could use rule number 3 and take the exponent and put it in the front. Exponent in front. Exponent in front. So it's 1/2 log a minus 2 log b. And that would be my final answer for that one. All right, so let's take a look at the last one here in this section. All right, so I have a couple of radicals here. Now, this here is actually saying log the square root of a, the square root of b, over the cube root of c. So both of these, the a and the b, are going to become halves. So it's going to be log a to the half, b to the half, over c to what power? The power is 1, the root is 3, so it's to the 1/3 power. Okay, so now I'm going to start separating. So I have a multiplication here, so that's going to separate a and b with a plus. And then I have a division here, which is going to separate with a minus. And don't forget to give everybody a log when we do this. So it's log a to the half plus log b to the half minus log c to the 1/3 power. All right, now I'm going to take my exponents. They're all going to go into the front of the log. So it's 1/2 log a plus 1/2 log b minus 1/3 log c. All right, so this is an acceptable answer, especially if it's in a free response. However, in the past, I have seen on the regions this written a little differently. And the reason why is because look at these first two here, the log 1/2 log A plus 1/2 log B. They both have a GCF of a half. They both have a half in front. So you can do the GCF, the greatest common factor, and factor out the half and write it like this. 1/2 times log A plus log B, close the parentheses, minus 1/3 log C. So notice that I only factored out the half here. I didn't factor out any logs. The logs have to stay there. It's only the half that gets factored out. So you would want to know multiple ways to represent something in case this is a multiple choice question and maybe you do this and you're like, oh my God, the answer is not there. What's another way that I could write this answer? So always look for a GCF when you do logs. Okay, let's look at the next section, and I just need to change my paper, so hold on. Okay, so now what we're going to do is we're going to go from the expanded form back into one log. Okay, so I have multiple logs. When I'm done, I should only have one log written. Okay, so what I want you to write on top here is any number, this is how you start, any number in front of the log, move back to the exponent. Okay, because remember, a number in front of log came from an exponent. Okay, so let's start here. Let's see, I have a number in front of log here, which is a 3. So that's going to go back to only my A, and my 1/2 is going to go back to my C. So it'll be log A to the 3rd power plus log B minus log C to the 1/2 power. Okay, so now what you want to do before you start putting things together is you want to put that back as a radical. Put back as radical. Okay, so remember, a 1/2 would be a square root. So this would be log A to the 3rd plus log B minus log the square root of C. All right, now once you take care of that, now you can start putting things back together. So remember, a plus comes from them being multiplied. A minus comes from them being divided. So this here becomes log A to the 3rd B minus log the square root of C. Now these are going to go back together with the division. Lose the log. Every time you put things back together, you lose logs. So it's log A to the 3rd B over the square root of C. Okay, so let's look at the next one. Number 2. Just going to move everything up a little bit. Okay, so notice I have a 1/2 in front of parentheses. So if I have a 1/2 in front of parentheses, that means I have 1/2 log A plus 1/2 log B minus 2 log C. All right, so I'm going to take my exponents. They're going to go back to each one of my A, B, and C. So it's log A to the 1/2 plus log B to the 1/2 minus log C squared. All right, I'm going to change my fractional exponents, these guys, to the radicals. Remember, 1/2 is the square root. So it's log the square root of A plus log the square root of B minus log C squared. Okay, now I could put these two guys back together with a multiplication, because remember, that's where addition comes from. Addition comes from them being multiplied. All right, so this becomes log the square root of A times the square root of B minus log C squared. All right, so now we wouldn't really write this like this. If they're both square roots, that means they both can go underneath one square root. So it's log the square root of AB minus log C squared. And now I can put these guys back together with a minus, with a division. So log the square root of AB over C squared. Okay, so that's it. Now, expanding and condensing logs, it takes practice. But once you do a few of them, that's why we're going to take a couple of days to do this, you will get really good at them. You'll be able to skip a lot of steps, and a lot of times you'll be able to go from the expanded form right into your last form, okay, of the single log and so on. All right, so I'll see you guys tomorrow. Have a good night.